Hello, my name is RD and we are going to solve this problem step by step. So our goal here is to find V0, and then the method that we use will be the node voltage method. Node voltage method. And let's see what are the step by step. The first one will be to label all the nodes and also extract the known information. So let's see what can we get from this circuit here. Okay, let's set the bottommost node here as our reference node. So we'll have reference node here. And or some other books call it the ground. But then here the convention is the voltage here is 0. So we set this reference node as 0 here. But now, right out of the bat, we know that this voltage here will be 4 volt, right? Why? Because that is a voltage source. And a voltage source is the difference between each terminal. So the positive one is here, and this one is here. So we know that this is 0. So if this is 4 volt, the difference will be exactly 4 volt. Good. And then we have two unknown nodes here. This node here, let's name this as VA. And then this node here, and let's name this node here as VB. Good. And what more information that we can take from here, we have Vx and V0 here. What is Vx? Vx is equal to the positive terminal, which is VB, and then minus the negative terminal, which is 4. Good. And also we have V0. V0 is the difference between two nodes, which is this VA minus 0. So V0 is equal to VA. And this is all the information that we can extract from the circuit. Good. Now let's move on to the second step. What can we do here? We need to assume the current's direction. Assume the current's direction. So for the branch with the current source, I just follow the arrow here. So it will goes up here, and here it will goes to the left. Good. And for this resistor here, I assume it is going down. And here I assume this is going to the right. And for this 2 ohm branch, I will assume it is going to the right. Okay. And now the most crucial thing is step number 3. We need to do KCL at each unknown non-reference node. Okay, there are 2 unknown nodes here, which is this one, VA, and then VB here, right? Okay, let's do KCL at VA, and then let's do KCL at VB. Let's do exactly that. Let's do KCL at VA. What does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay. There are no currents that goes into this VA, so I will have 0 here. Okay. But then we have a current source here that will be exactly 7 ampere. So we'll have 7 here. And then let's move on. So I will have plus. We will have this current here. But the only thing that we know that this is VA and 0. So I'll have VA. The current comes from VA and the current goes to 0. So I will have minus 0. But then this is voltage. We need current. We need to divide by the resistance between them, which is 3. Good. Now we have this current here. So we will have the current that the current comes from node VA here, so I have VA, and then the current goes to VB, so I'll have minus VB, and so I divide by the resistance between them, which is 1. Good. Now we can multiply both sides here by 3. So on the left hand side I still have 0, and here I will have 21, and here I will have 3 and 3 will cancel each other, so I will have VA, and then we will have plus 3 VA, and then minus 3 VB. Good. And VA plus 3 VA, that will be 4 VA, right? 4 VA, and then minus 3 VB. Good. And that will equal to minus 21. Okay, let's save this as equation number 1, because we still have one more equation from VB, right? So we will have 4 VA minus 3 VB, that will equal to minus 21. Good. Okay, I think let's move it to the left. Okay, we still need to do KCL at this node here, at node VB. Let's do another KCL, but this time at node VB. Let's do that. KCL at node VB. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out, right? Okay, we will have this current that goes in, and this current comes from this 4 node, so I will have 4, and then it goes to VB, so we'll have minus VB. But this is voltage, we need current, so we divide it by the resistance between them. So we divide by 2. And here we play the same game, so I will have plus, we will have VA, and then minus VB, because the current comes from VA and it goes to VB, divided by the resistance between them. So I'll have 1. And then we have another current that goes in here, which is 2Vx. So we'll have 2Vx. However, Vx is VB minus 4. So let's rewrite that. So we will have VB minus 4. And I think that's good, because that is all the current that goes in. The only current that goes out is 0, because there is no current that goes out. Okay, we can multiply both sides here by 2 then. So we will have 4 minus VB, because 2 and 2 will cancel each other. And here we will have 2 VA, and then minus 2 VB. Okay, 2 multiplied by 2 is 4, so I will have plus 4 VB. And then we will have 4 multiplied by minus 4, that will be minus 16. All of that will equal to 0. Good. And now we will have 2 VA here. And then here we will have minus VB minus 2 VB, that will be minus 3, minus 3 plus 4, that will be plus VB. Okay, and then let's move this 16 to the right hand side and also 4 to the right hand side. So we will have 16 minus 4, that will be 12, right? And I think that is our second equation. So we have equation number 2 is 2VA, and then plus VB, and that will equal to 12. Good. Now we can move on to step number 4, which is solve the equation. Solve the equation. We have 2 equations with 2 variables. We should be able to do that using linear algebra. So here I will use elimination. Here we multiply the first equation by 1 and the second equation by 2. Why? Because 2VA here will become 4, and we can subtract it and it will cancel each other, right? So we will have this one will be 4 VA minus 3 VB, and that will equal to minus 21. But then here I will have 4 VA and then plus 2 VB, right? Plus 2 VB, and that will equal to 24. Okay, we can subtract this, right? So we will have minus 5 VB, right? Minus 5 VB, and this one will be minus 45, which is good because we can divide minus 5 to both sides. So we'll have VB is equal to 9 volt. And let's save that because this is one of the most important values here. We know that VB is 9 volt. Okay, but then from VB here we can find out VA by substituting that is VB to equation number 2 here. So we know that 2 VA here plus VB, but VB is 9, so I will have 9 here is equal to 12. Okay, we can subtract 9 to the both sides, so we'll have 2 VA is equal to 3, right? So we'll have VA here is 3 divided by 2, so I will have 1.5 volt. So we know that VA is 1.5 volt, but then that is not the question is asking. So the question is asking us about V0. So the last step will be answer the question. Okay, but then we know that V0 is equal to VA, right? From this equation here. So we already get that V0 here is equal to 1.5 volt. And that is our final answer here. V0 is 1.5 volt. Okay, hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.